Welcome to FlowStars, candid conversations between Dr. Peter O'Toole and the big hitters of flow cytometry, brought to you by Beckman Coulter at Bitesize Bio.
In today's episode of FlowStars, I'm joined by Paul Smith from Cardiff University, who shares his advice of buying children's toys.
That stuck with me, that did. The fact that technology can stop you having to sleep in the lab, definitely.
And his experience of working at a nuclear laboratory.
Not us, we were in the biology branch, we were playing with cells, but in other parts. And if that happened, there would be a massive radiation flash, and basically you were dead at that point.
All in this episode of the FlowStars. Hi, I'm Peter O'Toole, and today I'm joined by Paul Smith from the University of Cardiff. Afternoon, Paul.
Good afternoon, Peter. How are you?
I'm good, thank you. It's been a while since we've met. So
yes.
usually at either conferences or grant committees.
That's right, yeah. Well, you're pleading for money. How's it going?
On the money side's okay, but maybe I just got lucky on that front recently.
Well done.
Thinking of which, this is going to, throughout today, we're going to chat about all sorts. And some of the questions I've never been able to ask you before, probably because we've been around people where we shouldn't maybe talking quite so openly. So I thought, what better than on a recorded chat to discuss it? And I know I've been fortunate in funding, getting research funding, and having it from EPSRC, BBSRC, MRC. So the whole, a lot of the UKRI that we're associated with, but you're equally competitive in all those different funding bodies, from Cancer Research UK, BBSRC, EPSRC. Is that your science being so diverse that enables you to apply for all those different funding bodies? Most people are restricted to one, and yet here you are, and you're able to go down all these different branches of funding avenues.
I think it's the people you know and you collaborate with. That's the reality. You become inspired by as well. But I tell you, if you look out there are people who can solve your problems for you and you can work with. That's what I've found. And the people I admire, the people I don't understand are mathematicians, right? I really don't understand them. It's another species. But,
you've never been able to sum them up.
Yeah, that's right. One at a time. But I think engineers have a superb way of thinking. Bioengineers as well, so in terms of putting projects together, how to push them through. And so I've been very lucky to work in a multidisciplinary sort of science in many ways. Cytometry has to reach out to instrumentation, biology applications, clinic, etc. So I enjoy that. I get bored too easily as well, so I get inspired by other people's interests. Yeah.
So if you look at the way in the UK, we have the government funds a variety of different funding bodies within it that puts it for more basic biological to the medical research, the engineering and physics research. So they're all sort of split out into these different pots, which tend to be working more and more together. Do you think that's the right way forward?
If it's focused on something they want to commonly achieve, yes. I think a good example of that was the relationship between the EPSRC and CRUK for advanced imaging centres. You can't do everything yourself. Science is multidisciplinary, whichever way you look at it. And so I think as long as there's a clear focus and a strategic need for something, you can assemble the people and the groups and the research councils, as they used to be called, shall we say, together to achieve that. But you have to look in all of those situations on not what is presented now, but what's going to happen in the future. And that's where the risk element has to come in, right? And that's why I think groups like Innovate UK should be partnering more with some of these organisations, because let's face it, they're the ones that should have a strategic view, as well as taking some degree of a brief from government as well. So it's for the longer view, those strategic alliances, and I've tried to do that with my science as well, rather than just what the immediate is.
That partly answers actually what my next question was going to be. You've obviously sat on many grant panels. I'm not saying you're really old when I say many.
Thank you very much. Yeah.
Okay, but I'm just looking at your grey hair. Sorry.
And no black eyebrows. What's going on there? My wife looks at me and I do that, and she bursts into tears of laughter every time. So there you go. It must be two different genes.
I'll be interested to see what happens as well. I'm going on the grass to see what happens with these. Anyway, I was going to ask, but you've also chaired many grant panels as well. And through that, I've been fortunate to be on the panels that you've chaired, and I found you an exceptionally good chair. But you must have some top tips of what makes a good grant application and what doesn't. So what would be your top tip to make it sell? And what is the biggest thing you shouldn't do when you're writing a grant application for anyone looking to get their next grant application?
Okay, I think I can say that without doubt that the thing people fail most on is the impact side of their science. And where you have to fill in, and it's usually the last thing you fill in on the grant application form, what's going to be the impact, etc., translation in some way. And people think that's an added afterthought. And you and I know on grant panels, very often the decision to go with one class one higher than another is, of course, that longer view, that impact. And very often, you can almost write the impact statement for the people having read their grant. So why on earth don't they do it themselves, right? It's either that they're not thinking that way, or they're not playing the game, or they're not really answering the question that's being asked. And that's the major failing point, I think. The science, let's face it, most people present their science in a way that essentially they should be the best person in the world to do it. In reality, they should know more about their area than anybody else, right? I always say that to PhD students. Remember, you've been immersed in this area, so don't take it off an examiner too much, So I think that's the one thing, the impact and the longer view, because let's face it, that's where the grant call comes from, trying to achieve something, not just give money out.
So that comes on to the next point. As a grant panel, we give money out. They get that funding. Do you expect that researcher to carry out the research exactly as they have proposed within their grant application?
From my experience of what's happening to me, if you suddenly come across something that means you can pivot to advantage and still stay, should we say, on the rails of interest for that grant, I think that's perfect. A good example, I think, was a BBSRC grant that we had, that we were following. Then suddenly something appears and you could not ignore this. So what do? Put it to one side, apply for another grant, examine it in 18 months' time, or capture the moment in some way, right? So capturing the moment of not going against the principles of the grant, certainly. Sometimes it's a really good idea just to talk to the grant awarding body and practice that pitch that it's worthwhile doing this. It should. Otherwise, you're undertaking contract research, something that can be done, but you're the one to do it and you complete it, right? And it's not contract research, is it, from research councils? It should be innovation right all the way through.
I think it comes back to what you said at the start, impact.
Yeah.
And if you carry on down what you first, a PhD thesis, you never end up in the third year where you thought you were going to be on year one. And it's the same with a grant application. You don't really ever finish up on exactly the same spot. Yes, it's got that area, but it's not a narrow line. It is broad. And
well, a PhD is a driving test, isn't it? It's whether or not you can be allowed out there with other people's money to pursue science that you have some inspiration behind, but also a need for that. So it's a driving test, really. So,
Paul, what got you into science to start with?
Oh, gosh. It sounds a bit strange to say this, but I wanted to be an astronomer when I was 9 and 10. That's because my parents bought me a telescope. Then suddenly the world opens up to you and you've got an instrument to handle. It's fantastic, right? I remember talking to my, 9, I would have been about 10, I guess. The teacher in the primary school said, I really want to be, an astronomer. And they said, no, there's no careers in that. There's no jobs, Do not take careers advice from any teacher whatsoever. Just don't do it, right?
Because why not, Paul? Why not?
Because they don't know what jobs are out there in reality. And I've got lots of examples of that. It's tongue-in-cheek, that, by the way, tongue-in-cheek. But the next step was that I read books on microbiology, the biography, basically, of Louis Pasteur. So by the time I was, 13, I wanted to be a microbiologist, which is ridiculous, really, isn't it? Yes. And that's because I was bought a microscope. So, be careful what you buy your child, because you can suddenly get them fixated on something. So I ended up doing medical microbiology as a first degree. So that's what inspired me in science, having access to instruments that you can play with and use. Yeah.
So if anyone gives you a toy, you get into it. So they bought you a telescope, you got into astronomy. You got into the microbiology because you were bought a microscope. Yeah. I guess that was about the age of 13, 14. So when you're 17, you got bought a car.
Yeah.
Does that mean you got into cars as well?
That's right, yeah. I'm looking forward to the electric wheelchair as well. I'm sure that's really quite an interesting technology. So, be careful what you buy your child, I tell you.
But you are a car fanatic.
A little bit, yes. I nurture my little car, as it were, which is a 350Z. Amazingly polluting these days, and we do trips out. There's one to Le Mans in 2012, for example, when I looked a bit younger, yes. And been very lucky in many ways. We've sought out living in places where there's a nice community. So there was a group of about 7 of us in open-top sports cars going on a long trip together. Great fun. So I wrap my interests into like people in the community, which is a great thing, So enjoy that very much.
I suppose if you've all got drop tops, you have to kind of open top cars. You have to go some miles just to be able to use it, being as you live in Wales.
That's right, yeah, absolutely. Well, sometimes I just sit in the garage with it off, and the fan heater on. It works really well for me. So there you go.
I can believe that, actually. Polishing the steering wheel.
In fact, sometimes my wife makes me go up there. I don't know why, but then we'll see.
So, from being a microbiologist, I think you did your degree in microbiology.
Yeah.
But then you went over to Canada?
Oh, yeah, that was... no, not quite. I ended up at the Patterson Labs doing a PhD studentship with the MRC. And in fact, believe it or not, I'd heard about the MRC, from being in my teens, because I used to subscribe to the New Scientist. So you see these adverts coming through all the time, I used to look at the adverts and when I was in sixth form, and I think, oh yeah, that's the thing to work for, the MRC. They're really focused, they know what they're doing, etc. And so what happened was I sought out MRC studentships when I finished my first degree, and I ended up at the Patterson Labs in Manchester. The Laszlo Leiter was there. But talking about inspirations, amazing. Alma Howard was the head of the radiobiology department, basically. And Alma Howard and Pelk, of course, named the cell cycle. So I got caught at that point into interest in the cell cycle. Let's face it, it's the most important thing on, in human existence. A cell only has to do, 3 things. Decide whether or not to replicate its DNA, decide whether or not to divide, and decide whether or not to die. Everything else is an adornment on that in terms of biology. So understanding the basic principles of the cell cycle and its central importance was something that sort of gripped me at that point. In fact, that was my first exposure when I was a student to flow cytometry, because we didn't have a flow cytometer, obviously at the Patterson Labs at the time. But my supervisor came along and waved this article in front of me from Nature, and it was the first DNA histogram generated by a flow. This is the early 70s. And I just finished 3 days of measuring pulse label mitoses by sleeping in the lab, and measuring them to get 2 full cell cycles, as it were, for an analyze. And he was grinning at me, saying, "See, you can do it in minutes." That stuck with me, that did. The fact that technology can stop you having to sleep in the lab, definitely. But after that, I actually ended up in Canada postdocing there. I think it's because of the old boy network, in reality, in those days, because your supervisor would know people, typically in the States. You had to have a North American experience. And they would say, "I've been in touch with so-and-so, how about a possible fellowship there?" So there was much more guidance in those days. And I was so excited because I was going to a large national laboratory. And I thought that's the way science was done. A big national lab, everybody working together. And I can tell you a bit more about that if you're interested.
So was it not like that when you got there?
Well, I hadn't realized that there were armed guards walking around the place, for a start, because it was the Chalk River Nuclear Labs, and that's a bit of an exaggeration about armed guards, but there was plutonium on site and a whole series of things. So even though I was in the biology branch, we had to be careful of where we were on the site because there were a couple of reactors, that sort of thing. And interestingly, my first exposure to that place in a non-radiobiological way, the first exposure was the safety lecture, where they decided to tell you about the different sirens that are involved in emergency. And there was about 15 of them that you had to learn, different types of sirens. And the worst one was, there was a typical one such as, ooh, 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 you had to close the windows and do various things. This is in case of release of radioactive material, which never happened, by the way, but they had to think about these things. And then there's this awful sound that was a little like this, absolutely like a sound from hell, as it were. And that was a flux detector, basically. In other words, when you get a neutron flux. So when you artificially put together a pile of radioactive material, not us, we were in the biology branch, we were playing with cells, but in other parts. And if that happened, there would be a massive radiation flash, and basically you were dead at that point. So your first job was to make sure nobody else came into the area. That was the safety routine. This never happened, of course, but I think they did this deliberately just to scare you. Yeah.
How did you find going out? It's a big change going from the UK over to Canada. How were you daunted, just from the personal experience of not the science, but actually just moving countries to do your science?
Okay, well, there's 2 ways of looking at that. First of all, Canada is wonderful. It's the most British thing in North America. So you fit straight in, and it's a land of immigrants in many ways as well, and welcoming people. It's superb. We have business there as well, even today. I have great friends there, but very welcoming, and they make a point of not being American in the nicest possible way, as it were. And what did somebody say once? Canada is like living in an upstairs apartment with a great party going on below. That's the idea. But we loved Canada. We fell in love with the place. Had 2 children out there as well, Canadians. And but the other side, we lived in a rather strange town called Deep River, which we loved dearly. But have you seen Twin Peaks? Twin Peaks is a TV series about a strange town in North America. It was like that because everybody in the place worked at the plant. So they were either metallurgists or physicists or engineers or mathematicians. So you can imagine what it was like at the local high school when they had the parents' evening, because the nuclear physicist would come in and ask the teacher why his child wasn't a prodigy, etc. So it was a rather strange place, just rammed full of professional people. It's like having an Oxford or a Cambridge dropped into the middle of a North American forest. Really weird, but we loved it.
So on that note, I presume you weren't brought up in a similar
No,
type of location?
you can tell from my accent I'm French. No, I'm from the north of England, Warrington. That's why I love rugby league, by the way. I used to play union, but I watch rugby league. And so you can't take the north out of the man, I don't think. I just feel not so much at home there, but I have certain resonances. And yeah. So I'm from Warrington, which is crammed between Liverpool and Manchester, of course,
So two very industrial cities.
Oh, yeah.
Warrington
well,
being on one of those
as a family, we come from silk weavers originally. And very interesting background because it's a history of the Industrial Revolution, how people moved around, even within relatively small areas. Our ancestors, shall we say, moved to Warrington because of the sudden upturn in the Industrial Revolution in engineering there and metalwork, etc. So, yeah, really interesting.
We should follow that thread another time, Paul.
Yes, absolutely.
Sorry. Couldn't help it. So you're now in Cardiff.
Yes.
Via, was it MRC down in? You went back to the MRC.
I went to, it was the MRC Centre in Cambridge for many years as well. Very happy there, but at some point in your life, you have to change and shift. And I was made aware of Cardiff, and I moved there in 95, 97. So, yeah. Always difficult when you've got children because they're, at school doing exams and things. And so I had to make the move over a period of 2 years. Which is, always difficult, but it's worthwhile doing.
So take your children stayed back in Cambridge?
Well, one did and one didn't, yeah. So, okay. So one came with me. Well, I went first, then one came as they went into the sixth form, then the next one came, etc. So you had to,
And so was your wife?
We eventually all moved as a family in 95.
Did your wife stay in Cambridge for that time?
Pardon? I used to commute.
But what about when the sixth former started? What happened then?
What happened then?
Yeah, because if you've got one in sixth form and the other one's not in sixth form, I presume.
We got a place in a little town called Cowbridge in the Vale of Glamorgan, lovely place. And then we would go home for the weekends, then come back, etc. So it was lots of shuttling. I did quite a bit of driving, but that's what parents have to do to make sure the children get through okay. So.
Well, if you weren't driving back to Cambridge, you'd have probably been driving to a rugby match or football match or cricket match and practice.
There you go. Yes.
That tends to be all our weekends are is driving one and then the other. And in winter months, that isn't much fun standing in the middle of nowhere.
Yeah, and then you've got the taxi services all parents have to do. Yeah. We should all be registered Uber drivers for our family, I think. So.
Yeah, let's not go down that path. So, for all that time, so you've obviously been MRC Cambridge, you've been at Cardiff, you've been at Patterson, you've been over in you've been into mega places. Who are your biggest inspirations?
Okay, I can either be logical about this, or I can be emotional, or I can be rather embarrassing. What would you prefer?
Oh, no, I was going to go emotional, but then you said embarrassing, so we've got to start there.
Okay, well, it's always embarrassing to say that you're inspired by a teacher, right? But in reality, it's my biology teacher who came from Cardiff University, believe it or not, originally. Di Rees, as we used to call him, Mr. Rees. And he was one of these people who was just highly motivating, strange individual in many ways, but we all sort of, anybody who was interested in biology thought he was super. He would do things like when you're 16 or so, you'd arrange for a group of us to go away to the Institute of Biology lectures. So we were visiting university campuses at that age, not just on an open day, to go listen to lectures and ask questions, right? Which was amazing, really, because I got this insight into what universities looked like, felt like, how they operated, the types of people who were in there, usually long hair, moustaches, bad breath and sandals. It was the sort of 60s, let's face it. And so in that way, I sort of homed in on university as our academic life relatively early. And he was quite inspirational. So any of his pupils that would go away to university would send their practical sheets back, and he would reproduce the university practicals in the school lab. So when I'm 16, I'm making slides, I'm extracting DNA, I'm doing God knows what in reality. Not always sure of what you're doing, but being exposed to that sort of lab work. So that kicked me off really. And then the different places I went to, there was always somebody inspirational, and I was very lucky, very lucky. I can go through those, but you know, there's one person that stands out amongst anybody else, and that's Jim Watson, the real Jim Watson, the cytometry Jim Watson, the medic, the real one, and at Cambridge. And that was the reason I actually went to Cambridge. Yeah. Oh God, you're actually using that, are you?
So, yeah, of course.
Yeah, that's the Jim Watson everybody knows with the glass in the hand. The drawing was actually done by the MRC art department at the MRC Centre in L&B and in Cambridge. And that's what people felt about him. He just motored everywhere. Amazing. I heard about flow cytometry in its real sense, I think, when I was in Canada. And I saw this opportunity for a position in Cambridge, and I'd missed the deadline for the application. Of course, you should completely ignore that, any deadlines, you know. So I immediately sent, believe it or not, a telex. That shows you something, doesn't it? A telex saying that, hold everything, I'm putting in an application, you know, as it were. And it brings people, your attention to people. So that was interesting. I'd looked at some of the early publications of what they were starting to do there. And I just thought it was a wonderful technology. You mean you can look at individual cells at high speed and analyze them? And he had an early instrument there, but he was building his own system. So I got in on that basically when I arrived. We even shared an office together as well. And there you go. It's and I've got so much time for he's a real polymath. There are inspirations who sit in silos because they're very good at something. They're usually like role models or people who can help you or inspire you. But a real polymath is somebody like Jim who would design equipment, work with people with experiments, go off and run an oncology clinic, go into the operating theatre, handle brachytherapy, and then come back and teach himself coding and software and engineer his own programs. You know, it was an inspiration to be with, really was. And I regard him as my, great colleague from those days. You know, yeah.
Yeah, I've never heard.
On a very personal note, if you don't mind me touching on this, Jim had an episode of not being well at one point, and his wife actually phoned me as one of the first people to phone, so I could go along and see him in hospital at a particular moment of crisis in which he completely recovered. But that was very touching because at some point your colleagues become friends, and then they become something else as well, you know. So anyway, a lot of time for Jim, and he's still doing his bit in different ways in different places. So yeah.
So you were there at not quite the birth, but around the birth of flow cytometry, I guess. Yeah. But at the same time, same institute, Brad Amos was there.
Oh, yeah. Well, Cesar Milstein used to come into my lab there. The nice thing about there, you could have your own lab. You got on and did what you wanted to do, you know, and you looked around. There was first talk I went to. There were 4 Nobel Prizes which sat on the front seats of the auditorium. That tells you something, doesn't it? And Cesar Milstein, who I knew very well, he used to come into my lab and use my equipment as well. And but of course, how should we say, international profile or fame mean nothing when you're in labs. You just get on and do things, you interact normally. And I do remember one day Cesar came in, you know, and he said, Paul, he's Argentinian, as you remember, and he said, Paul, I can't get the your spectrophotometer to work, and I was busy, and I went, oh. So I went out, and he closed the shutter by mistake, so there's no light coming through it. Oh, flick, and there you go. Then I realised who I was. As I walked out, I realised who I was talking to. But you just saw them as people in the lab, as it were. That sort of thing.
A nuisance.
Brad was a very good example of that. Brad was a good example of a problem solver. He introduced me. Well, what happened with some work with Jim Watson, that we were exploring the far red part of the spectrum for fluors, because that was underrepresented. And so we organized the flow cytometer system to be able to detect in the far red. And I modified a spectrophotometer as well, and discovered a fluorescence signatures in the far red of different probes and drugs. We were very interested in drugs because we're interested in oncology. And went to Brad, and basically he was setting up his BIRAD type system, as it were, with far red detection. And that just opened up a whole series of experiments for us. And he just loved that idea of being able to modify technology to enable another door to be opened for you. Yeah.
That's a real.
Brad, remember, is somebody who would walk around a supermarket with a small spectral analyzer in his pocket to pick out things and just have a quick look at them to see if there's anything interesting there he could pursue. That's true.
I didn't know that.
Did you know he was a diamond polisher? He was a gem polisher as well. Yeah. So here's somebody had a very refined set of interests, I tell you.
There are some bizarre hobbies amongst, in Brad's case, physicist microscopist, I guess, and with what was then the first proper confocal microscope.
Yeah, well, of course, you have to pay due respect as well to the MRC workshops. That's an example of an MRC workshop engineering. These are the I inherited parts of Jim Watson's flow cytometer system when we took it apart, and I tried to reassemble it, for God's sake, in Cardiff in various ways. But that's an example of MRC engineering in those days. So precise, so beautiful. In fact, you can just fondle these. They're wonderful. I keep them on my desk as a reminder of those days. But the MRC workshops were something special there in Cambridge, because you would go with an idea and they'll say, yeah, we'll build that. And the engineering was superb. So Jim had that capacity of being able to conceive of something, then have it translated on site into a working instrument, and surrounded like lesser mortals like myself who wanted to use those pieces of equipment in different ways. And then they would modify them according to what you wanted to pursue. So it's not like buying off the shelf anymore and being convinced about somebody else's capacity to do something. It was live engineering. It was wonderful, wonderful.
Yeah, and as you just illustrated, they even designed paperweights, especially for your desk pool.
That's right. Yeah. Well, in fact, I have this idea. I keep looking at these things. I must admit. Let me show you. Just bear with me 1 second. There you go. There you go. It's a mother, a father, and a small child, isn't it? Or it's the first, second, and third of some cytometry award. Who wouldn't want one of these mounted as an award? Yeah. So
not bad, is it?
Third place, very nice. Beam splitter. There's a unit for bringing in it. I think it was the red beam at that time. That's the runner-up, and there you go. And there's the full Monty for the winner of the award. You never know. I think that's a good idea for an award sometime. Get in touch with the RMS on that.
Yeah. Or Isaac. Thinking of Isaac, you were also Isaac president.
Yes. Yeah.
Oh gosh, I couldn't tell.
That was in 1962. Yeah. No, it wasn't.
2012.
It's about 12. Yeah, about 12. Yes. I've been involved for a while actually, because Jim Watson introduced me to SAC, the original society. Well, the MOFT Society anyway, and we had the SAT conference in Cambridge, so we were all recruited into this, of course, to help out. Jim was great, but he was useless at organising big events in reality, because he thought they were basically lab parties, just on a bigger scale. And so he, for example, thought, I'm not going to bring caterers in to do coffee and tea at the breaks. I'll just put a couple of kettles there and some sachets of coffee, and people can help themselves. Well, if you calculate it out, 800 people trying to help themselves to coffee in 15 minutes doesn't work. So, but that was Jim for you, and that was my introduction to SAC, which then became ISAC. So, yeah.
And enjoy the time as president.
Joining an international society rather than a domestic society does open up your potential for staying in places and overnight if you ever get stuck anywhere, because you know so many people. But in reality, it's a great way to explore other views of your science as well. And not so much collaboration, but learning from others. I know that sounds a little corny, but that's the truth. And at the time, of course, there was lots of exciting things happening in the large national labs in like Lawrence Livermore and etc. and Los Alamos. And it was a way of understanding what was happening there and the people behind them and their motivation as well. And of course, you can translate that thinking into how you pursue grants as well and how you organize your research, because you want it to be competitive, but not following, as it were. If it's not, you want it to be competitive and almost parallel, so that you can learn from others and progress together as well, which is slightly different from how some of the postdocs used to be organized in North American labs, where basically people would be given, more than one person would be given the same project, and the first one to publish won. It's a different attitude. So, yeah.
I think, as you mentioned at the start, collaborating and team science is really important, probably more important now than ever before. You bought Cyto Innovation.
Sorry?
Cyto Innovation.
Yes. Yeah,
that was one of your innovations, wasn't it?
Well, yes, it was actually. Yes, people forget this. And Cyto, I branded. I was driving along one day, and I thought, we've got to change the name of the society. I think it was president-elect at the time. We can't have the XX1V International Congress of the International Society for Analytical Cytology anymore, as it used to be called. That is not catchy in any way. So I thought, in reality, with Cytometry as a publication, the Part A, we have ownership in some ways and recognition of our own scientific domain, right? And so why not capture that as the brand, as it were, for the International Congress? I thought, Cyto. So I immediately thought that's the way to go. And everybody thought it was a good idea. And so, and the original idea, in fact, was to have an umbrella name for an international meeting in which you could partner with other organizations without them feeling that they're attending your meeting, as it were, as an annual congress, right? So it allowed you to partner under the umbrella of Cyto, even though we own that, as it were, without feeling that you're joining somebody else's congress. So that was the concept, to make it easier to partner with different groups in different times. Yeah.
What do you do in your spare time then?
What spare time? It's one long list of interviews with different interesting people. I made an exception today, Peter.
Make it a interesting person. Yeah, cheers, Paul. Go on.
So, no, I have this pleasure and amusement. I'm becoming like my father. My father could build things and create things, as it were. And so in my spare time, if it's raining, I have my own workshop and I build interesting furniture, as it were, out of quirky things. So we'll move that on. I'm not supplying any photographs of that.
You can't move your camera to show us any of that quirky furniture, no?
There's one behind me. No, you can't see it now. That's just a coffee table, 2 coffee tables actually. Yeah, and of course my wife thinks, oh my God, not another coffee table, you know, that sort of thing. So I'm thinking about making them so they can stack now. But anyway, but you know, out of an old wakeboard of my son's, I converted into a table. Looks really cool. So I like doing that. I like fixing things. I prefer to do things myself and get somebody else in to do them. I only bring people in when I've made a mess of something and they have to fix it, basically. Yeah, so there's that. Enjoy messing around in cars and with cars, etc. But I think it's things to do with your hands and, you know, achieving things. Something that has a product at the end of it as well. So
in that case, do you cook or wash up then? If you like making things with your hands?
I didn't know there was a choice. I must go into this a bit more closely. I didn't know there was a choice. I thought you had to do both, right? If you don't mind me saying so, I do all the cooking.
Yeah.
I've done all the cooking for years, as it were, and because I like to eat well, and so.
Are you saying your wife's a bad cook?
Yeah,
but is that what you're saying? Are you saying your wife's a bad cook?
No. Is this going public? So I like cooking Italian and experimenting. I never follow recipes, and I think that's a bit of my failing, actually. I don't like being told the right way to do something. I'd rather work it out, as it were.
You can never follow. Recipes are there as a guideline. You never follow it to the letter.
Exactly.
Ingredients change.
Exactly. That's the thing I have. So I don't even know what I'm going to produce at the start when I'm cooking, because I'll change my mind halfway, as it were. So yeah, we haven't lost anybody yet, though. That's the main thing.
So Italian's your preferred style. What do you not like cooking?
What do I not like cooking? I won't touch baking at all.
That's because you have to follow a recipe for that.
Yeah, well,
you
don't immediately see if it's worked. You have to wait until the darn thing comes out of the oven, you know, and then the anticipation of failure is just too much for me, basically.
Yeah, I struggle to cook Asian food.
Asian food?
Right. Yeah, I really struggle to cook Asian food.
Yeah, I think it's having the right ingredients and the range of them and understanding how they're put together. That's my failing, I think. I don't look into that. But I like the chemistry of cooking as well, you know. I do things, I think, I wonder if that will work. Oh, no, it doesn't. I wonder why, you know. So this is probably because I've had to get into formulations recently. That's the problem.
Well, I was going to say, thinking of chemistry, and don't forget, you started out as a microscopist to a hobby scientist at home through to a microbiologist. Now, arguably, you've had a lot of chemistry influence as well.
Oh, I can bluff my way in chemistry. I can really bluff. I've got some great people in the background, one of which is, of course, Lawrence Patterson, a long-time colleague of mine. And he's a superb medicinal chemist as well. And in the next lab to me was Paul Workman, of course, in Cambridge, and he was quite an inspiration. There's somebody who works really hard, Paul Workman, and he really does. And understanding how chemistry can direct you in the right way to a solution in biology, whether or not it's a probe, a reporter, a drug, a modifier, or whatever. It's in your hands to create these molecular tools to investigate biology. And talking about inspirations, one of the early things I read about was the history of Paul Ehrlich, of course, Salvarsan, and developing really the first chemotherapeutic, I guess, in some ways. And that was an inspiration as well, in that you can think about molecules and create them in a way that can be used as either tools or medicines. And it's that duality of purpose that interested me in many ways.
So this is track 5?
Yeah, that's one of the anthraquinone probes that we developed. And I remember looking down the microscope the first time I saw this. And we were going through a series of anthraquinone modified drugs and hypoxia activated prodrugs. I was working out their mechanisms of action. And this is right all the way through to Cardiff. And I looked down the microscope one day where we'd modified one of the molecules in a unique way. And suddenly it was just lighting up all the nuclei, right? Then we understood some of the rules associated with molecular targeting within the cell, just at that moment, which was quite something. But the main background to this, I guess, was my understanding of far red fluors as well, because having the instrumentation to look in the far red allowed you to look for signatures in that area. And also getting rid of this idea in my head at the time that all probes and fluors have to be brighter and brighter and brighter. You know, the closer you are to one for a quantum yield, the better, as it were. That's not the case. It's all about signal to noise and affinity. That's the reality. So if you have a high affinity binder, even if it's got a low quantum yield, you'll still get a signal. In fact, the signal rises above noise very nicely at that point. So looking for low quantum yield fluors with high affinity, with a medicinal chemistry background that allow you to understand how they enter and target objects within cells, it was the key to our work in that area.
So I'm presuming from that, you never set out to design a live cell DNA stain.
Not a DNA stain, but a DNA targeting drug. Right.
Yeah.
So we went to the drugs. Look, in fact, what we were doing, I'd previously in Cambridge, I'd decided to get into molecular targets and looking at DNA topoisomerases, which I found fascinating. Molecules that can unlink, unknot, and detwist DNA as part of the natural process, and also as part of regulating whether or not the integrity of DNA is sufficient to allow a cell to divide.
Have you been practicing that hand move?
No,
Is that what you do on the dance floor? Is that one of your...
That's right. That's right. In fact, I look back with embarrassment because one of the easy ways to do this, I used to, this is just the cable running the computer, but I used to do this with a microphone cable when I was giving a talk. DNA, double-stranded. You do that, and then you get a superhelical twist. So how do you unknot that when you want to translate a molecule along it? And in one go, you show people how topoisomerases work. And the fact that there were certain drugs that could trap these molecules on DNA and cause a lot of disruption is the basis of a lot of chemotherapeutic agents, of course, adriamycin, VP16, etoposide, things like that. And we were looking at a new range of drugs, and Lawrence and I were trying to identify ways of targeting those more succinctly to selectively to DNA, so they would track the consensus sequences that topoisomerases used to bind. So it was a molecular targeting exercise. Then, because I was involved in far red flow cytometry, because of the Herx dyes and things like that, it suddenly appeared to me that these could be modified in some ways to produce probes and stains. Yeah, that was it.
So serendipitous in a way.
Oh, absolutely.
To come across. You then
Louis Pasteur said it's chance favors the mind that is prepared, right? And that is, and being prepared is usually being in the right place at the right time with the right people. So it's nothing to do with you in the end. It's just sheer luck.
But then you have to ride your luck, because if I could just get one more background, which I think I didn't realize this. I really had no idea. But you spun out. So you actually, you had this dye. It's no good having that dye, DRAC5, in your own lab. You need to make it available to people in a supportive, reliable manner. Hence spun out, and you got bias data, which I'm quite fond of as a company. We've used quite a lot and worked quite closely with Roy Edwards, and he's been a great help. But I didn't know you had all these other in-outs.
You get to that point where you, if you're in cancer research for so many years, you have to deliver and not just live off the career, right? And if you're involved in trying to develop therapeutics, if you believe in something and you want to see it through to the clinic, you've got to sort of commit to doing that in some way and not just hand it on as a baton race.
Well, that's what I was about to ask you, because I think a lot of academics see that they've got a compound, it's interesting, it's good. They think a company should then just buy it off them and do something with it. And it doesn't often work like that.
That's because there's a valley of death. There's an abyss between the great ideas and they've been translated or handed onto some sort of vehicle that can take it forward. So Biostate is set up basically to invent new dyes because we use them in the lab. You know, it's nothing better than inventing things that you want to use, not just sell, as it were. And we have an inspirational CEO in Stefan Ogrodzinski as well, a superb background. He's flown, you know, he's flown supplies into areas in Africa under fire, etc. You know, there's lots of stories there, I tell you. He's a very special individual. Anyway, and very credible and ethical individual, sort of person you want at your side in any endeavor. And so the three of us started, Lawrence Patterson, Stefan Ogrodzinski and myself, started Biostatus with the idea of not being a lifestyle company, just enjoying the ride, but trying to achieve something real in business. And we got a Royal Society of Chemistry Award for it as well. And however, also as an opportunity for other things. In other words, create your own environment in which to innovate. Just don't rely on other research councils. So we've eventually spun out 3 different companies, all based on our own input of venture, not receiving money from anybody else. In other words, doing it yourself. And that means 2 things happen. First of all, you go in the direction you believe. And secondly, you start to learn the process as you go along. You know, experience is something you need just after experience is something you get just after you need it, if you put it that way. So you learn about things as you go along by trying to do them. And so we created these opportunities, and one that we're very committed to at the moment is oncotherics, which is a new class of anti-cancer drugs that we're pushing forward. And we've been relatively successful so far, and we're hoping to push this into the clinic in one way or another over the next 12 months, if not 18 months.
So it's a huge step to go from the world of academia and actually taking that step to start a spin out. It takes a lot of effort and time, and I'd imagine, was there not a fear that your academic career would suffer because you had to put effort and time in there?
There is a choice in the end. So I stepped down from the university. I'm now emeritus, right? Because in my head, I didn't want any conflicts as well. So I decided you reach that point in your life, I guess, where you have to make positive decisions. And the best way to make a positive decision is not when you're forced to, but when you've got other like people around you are thinking in the same way. So having a group of 3 of us helps.
But did you do that at the start of Biostatus, or once Biostatus was established?
No. It became clear that Biostatus was teaching us things about spin out, about business, about how to approach things, how to have relationships with different larger organizations, etc. And in teaching yourself these skills, it de-risks what you want to do in some ways, because your eyes are a bit more open. And I think this is why in ISAC, I was interested in introducing innovation as one of the tranches, shall we say, within this society, because there are lots of people out there who want to take these steps and want to learn from others and know that it's worthwhile as well. It's a great journey.
So you have, I've got to think about this carefully, you balanced your academic life with the startup of your first company, and you managed to do that and go through. How do you then balance having an academic career, a startup, and your family?
It's very easy. I used to work late until about 1, 2 in the morning, right? First of all, I was always able to work late, but that's the wrong thing to do. Make sure you engage with family things. That's what we've always done, and our local community as well. But I tell you, it's having people around you who think the same way, that you can share and delegate and share tasks together as well. So doing it by yourself is probably something I wouldn't have done if we hadn't have created Biostatus as this sort of first step opportunity to see how to do these things as well. But it's definitely having the right people around you. But that's my family, very proud of. My daughter there, very shy and retiring, one with the hand in the air. And she's leading on environmental matters for Scottish Power on their large wind farms now. You know, she's somebody special.
And if she works for Scottish Power, can she get me a discount on my electric and gas? Because they're just putting up my price at the moment.
Just set up the extension league and she'll sort you out. And the guy in the white, that's Anthony, very proud of. He really is a bit of an entrepreneur himself, pushing himself forward. So he's at that side of my spectrum, as it were. I think Eloise is in the middle, my daughter. And the guy just above Eloise is Adrian, our middle son, and he's more sort of, he loves Excel sheets and data, and so he's a bit closer to me in many ways. It's good to see that some of your genes get sliced up and, you know, shared out. And that's my wife Barbara, and our daughter-in-law's behind. That's my wonderful father who passed away earlier this year.
Oh,
and semi-natural causes, as it were, during lockdown, but he was living with us, and that's my mother who passed away previously. But my father taught me how to be patient. I'm a very impatient person, but he was rock solid in that. And he was a frustrated technologist as well. He was a precision engineer, and of course the war disturbed his career path. But he was responsible for building the air braking systems on some of the RAF's fighters, things like that. So he was, and of course he didn't buy me toys. He bought me, for example, a full working model of a conveyancer forklift truck when I was 9, because he thought it was really cute, and they were working on conveyancer forklift trucks at the time, as it were. So I tell you, it's what you buy your children starts to set them off in potentially just the right direction.
Yeah, no, my dad bought me all sorts of tools as a builder, and I didn't want to go in the building trade.
You wouldn't have been able to hack it, I'm sure.
I can't hang a shelf up straight. There's no point.
I can see that from the background.
Yeah, that's just the angle. Oh, I got my dad to do it.
Okay.
I'm not. No, I do. Actually, I think I might have done that one myself. I've got to ask some more personal questions. Actually, what sort of music are you into?
Oh no. Okay, right. I'm unfortunately, being a northerner at that time of my life, R&B and soul was part of my upbringing, right? So I could even remember all the code numbers on all the different records, as it were. You know, pathetic, really. Yeah. So R&B and soul. Then, as it went into the 70s, especially having the North American experience, you discover West Coast, you know, folk, etc. So it's quite an eclectic mix, actually. I have a penchant for opera as well, so it's everything, you know. And my daughter Eloise, actually, she's inherited that ability to just explore different genres of music, and we go to live concerts, but I'm deliberately not going to tell you which ones I go to, otherwise you'll poke fun, as it were.
Okay, what's your favourite album?
What's your favourite? Oh gosh, it must be a Neil Young album, After the Gold Rush, because that opened up things in terms of West Coast music, American folk, etc. And it just hit at the right time. I'll say After the Gold Rush, Neil Young.
At home at the moment, what would you do? Read a book or watch TV?
I read papers avidly, keep up to date. Yeah, right.
You buy newspapers?
I read virtually online most of the time, I must admit. For spots of sanity, I read the Independent Eye now and then. But I tend to take in different news feeds because I like to check things, believe it or not, to make sure I'm getting the right information.
Balance.
It's all the more important to do that these days.
Yeah, well, I think you look at the British press. I always look at I always look at the front pages in the morning. You can get the website and look at all the front headlines, and they could be one story, 2 sides. And I do like getting that balance.
Yeah, absolutely. You've got to be careful what you release, though, because I remember Paul Workman saying once to some reporters that they had a really interesting lead compound. So it went on the wire throughout the States, and people were phoning him up and saying, "You've got a compound for treating cancer that's made of lead?"
Yeah, no, I'm already there. Yeah, I'm already there. So you read newspapers. If you were to have do you ever watch TV? If you do, if it's TV or a film, what's your preference?
Yes, but I'm very much a factual program person because it's a bit boring, but I like to learn something from programs as well. But like comedy, good. I have my favourite comedians, you know, that sort of thing. Milton Jones, for example. I think I like the working of the mind there.
Any one-liners and a play on words and puns?
Correct. Yeah. Well, I've taken various tests to understand what your personality is, and apparently I'm a word master. Not with a northern accent. I could never be a word master. But I do enjoy manipulation and use of words, which sometimes get in my way of saying things simply. So it's not always the best characteristic to have.
So I've got two more questions because we are out of time. First one is, what is your favourite science? And if you can't think of a science one, just what is your favourite joke?
Favourite joke? Am I allowed to plagiarise?
Yeah, of course.
Okay, a Milton Jones joke. I love the expectation in a joke and the visual image and then the twist. And you should be able to get the punchline at the end, right? Before it's delivered. Then it's even funny when it's delivered. So forgive me for this. This is nothing to do with me. I give my due respect to Milton Jones here. So he was saying about his father, who was unfortunately had up for being a peeping Tom. And he died recently. And apparently he used to drill a hole in the floor of his house and spy on people below, in the apartment below. But he died recently, and I like to think he's up there somewhere looking down upon us. but there's no delivering that, but that's that play on words. And favourite science, yeah?
Favourite science joke?
Favourite science joke? Oh, I don't find anything funny in science. It's far too serious, and I'll leave it at that.
Okay, and very finally, what is the next big thing, or what is the biggest unmet challenge that we need to address in science?
The harnessing of big data, collective knowledge, to effectively build highly predictive models so that money is not wasted on wrong directions in research, right? Because lots of people pursue research, and I'm guilty of this myself, research avenues which if you knew more about that area, you wouldn't pursue. It has the advantages of uncovering unexpected findings by chance, but I think we have to have a more, how should we say, a more efficient way of using research money for purpose. Yeah, the drug and pharma industry know this, certainly in terms of trying to predict early failure. But I would say that's the biggest step forward, effective modelling using big data or appropriate data. Not just fumbling around in the dark to see if something comes out of AI, but actually a real predictive approach to modelling. So I think that's where we're going. And in fact, in reality, that's exactly what's happening in real life. When you buy something, people can predict what you're going to buy next, etc. Why not harness this thinking to navigate a better and more efficient way through science?
Nice answer. Paul, on that note, I will thank you. Thank you for taking the time today to talk to us. It's been great.
It's been a pleasure. I was great to see you, Peter.
See you again
All
soon.
the best.
Bye.
Cheers. Bye-bye.